Our first speaker on the stage is Sofia Konchakova. She's a researcher at Humboldt University of Berlin. She will be presenting effective context tuning strategies for retrieval-augmented generation systems. In this session, she will explore advanced strategies for managing context in RAG systems, including selecting and weighing relevant passages and dynamically adjusting context size. Please give a warm welcome to Sofia.
Okay, hello everyone. My name is Sofia. Can you hear me well? Do I need to adjust anything? Okay, good. So, briefly, the topic is called Content Management for RAG Systems. I will talk shortly about myself. You might have seen me in DSC Adria this year. My topics of interest here: machine learning for Internet of Things, AI consulting, RAG systems, obviously. Sorry, I have a photo shooting here. And MLOps, because it's here to make our life harder and easier simultaneously. What can I add about myself? I'm not a morning person, and I have LinkedIn. It's here with QR code. Okay, but let's deep dive to, should I make it a bit lower? Because I'm breathing it very loud, and I can't, okay. Okay, agenda for today, very briefly, very shortly. I will remind what is RAG. I will also remind what data we can use for RAG, and we deep dive into retrieval management, and we'll discuss chunker, rerunker, retrieval strategies, all of this. So, without any further words, what is RAG? So, RAG was initially proposed by Patrick Lewis in 2020, and he initially wanted to combine parametric memory. It is our model trained to weight, so our trained memory with non-parametric memory, our external database. On the slide, you can see some vanilla version of RAG, how it's often called. So we have a user query, it is being passed to retriever connects to our database, retrieves relevant chunks together with query being passed to LLM to generate the response. For now, everything looks simple enough. I will try to make it a bit harder for you. I'm still continuing to breathe in it. I can't do anything with it. I'm sorry. So, why do we need RAG? First of all, we want to reduce costs. We do not want to train the model because it's too expensive. It's pretty flexible. We can use it with various data sources in various industries, which is nice. And we have higher accuracy because we have our external or only our unique knowledge, which can prevent some inaccuracies that our generative AI prone to. Some boring stuff again. So traditional MLOps usually described in these 4 steps. So we need to define business problem we are trying to solve. Then we have some data management step, some machine learning where we have model training, and then we deploy and monitor our system model. Well, it is not linear path, we take steps back, but that's not what I'm trying to say. What I'm trying to say is that when we have RAG, we do not have this machine learning, so training the model part. Instead, we have 2 new steps. We want to manage our model, and we want to have prompt management. In this presentation, I will cover only a part of model management. So, we will move to our data. Very briefly again, what data can we use? Good news and bad news for those who will build it. We can use almost everything. We can use text, we can use images, we can use videos, though it requires some additional steps of pre-processing. We can use PDFs, JSON, you name it, and some tables. Though I learned it hard way, and I will remind it to everyone, though RAG supports various data formats, it may not always be the best option. Sometimes just good dashboard with data connected to the data warehouse will be more effective and efficient. I will just, again, repeat it. But let's assume you know you want RAG, and you want definitely to do it. Your data should be streamlined and should be in the format of a data pipeline. And we want to ensure that our data pipeline is scalable, and there is no performance degradation and manual intervention, of course. We want to be able to monitor and observe our pipeline, so we have some logs, alerts, errors, everything. And of course, some functionality. We want to be able to clean, normalize, and enrich our data, depending on what we need. Last but not least, very important, we want to automate, including timely data updates, because this data is kind of the heart of our system. We want to have only relevant data. We want to have automatic, timely data updates because we don't want any garbage old data. This old principle, garbage in, garbage out, stands here. And now we are moving to the harder part. So, when I said model management, I implied managing two key parts of our system. It is retriever and generator. The retriever is responsible for fetching relevant information from the external database, and this relevant information will be our non-parametric memory. Generator combines the query and this relevant content to produce the response. And when we talk about retriever, there are lots of moving parts. We need to choose the embedding model, we want to decide on retrieval strategy, we want to define what's optimal chunk size, what chunking strategy we can use. There are lots of moving parts, right? I'll cover some of them. And some of the steps I also think is important to say will be included in our data management pipeline later, but as they influence the accuracy of our retriever, I will discuss it in this part. Okay, I need to breathe and very loud as I can hear. So our question, to chunk or not to chunk. I will discuss chunking. Chunking is a process of splitting the text. Think about like a huge sandwich, you're trying to eat it and it's very more comfortable to eat it in smaller chunks. Or you try to find relevant information and you know that this chapter is relevant. You don't want to look through the whole book, right? And when we talk about optimal chunk size, we know that the longer or larger chunks, they can dilute our relevance. On smaller chunks, they can break context flow. So we want to have some balance between semantic preservation and retrieval precision. But also, we want to make sure that we optimize for efficient token utilization and we ensure that we know our LLM token capacity constraints. Some people say that technical documentation is better, well, it's better to chunk technical documentation with smaller, focused chunks. And so also they say that for narrative context, you can use larger chunks, but there is bad news. There is no one-size-fits-all approach. You need to try it. And chunking isn't always necessary if you have short enough documents. And someone told you, yeah, but for RAG you need chunking. Sometimes you don't need. Sometimes it's better to keep your documents intact if they are short enough. But let's assume you decided to chunk, right? So what options do we have? We start with the basic one. We start with the fixed size chunking when we split it, given set by setting a fixed number of tokens per chunk. Well, advantages: simple, efficient, consistent chunk sizes, nice, though potential loss of context, and it's inflexible with our content length. If you want to have something more advanced, well, then it's recursive chunking, when we are trying larger separators first, and then we move to the, well, our splitter tries larger separators first, and then it moves to smaller separators, like from paragraphs to sentences, to get to this desired chunk size. Advantages: again, preserves natural document structure, reduces context fragmentation, though higher computational overhead, and some people might say that it's more complex to implement, though LangChain has perfect implementation for you. It's not so difficult as it looks. But if you want difficult, we can move to semantic and agentic chunking. And semantic chunking is splitting the text based on a meaningful units. So it looks at the embedding of the text and tries to find this perfect breakpoint where the text is closer. In one chunk, we keep the text that is closer similarity, and we split when they're not so close in similarity. It's good for preservation of context, and it leads to reduced information loss, though it requires sophisticated NLP models and produces chunks of varying sizes. So when we talk about semantic chunking, think of it as sorting books by topics. So it's art, it's history, it's math. And when we talk about agentic chunking, it's more like sorting books by purpose. So this is the book to study, this is a book to have fun with, how weird it might sound. So an agentic chunking uses LLMs as active agent to split the text intelligently based on the content, context, user needs. It leads to more intelligent splits and purpose-aware chunking, though, again, higher computational cost, the highest, because we need to call LLM every time to split our text, or document, whatever you call it. What I personally find the most disappointing, it is modern technology and has limited standardization and low maturity level, so, well, it might be a hurdle to implement. We discussed chunking, but we still didn't discuss retrieval strategies, and here I will cover some basics of it. So we have a sparse retriever, the most basic one. It uses keyword-based matching, creating, so I will give an example. We have these two sentences. I'm speaking at DSC Europe, and I speak about rock. We do not use stemming and lemmatization, so we, just for the sake of example, we create this vocabulary where each word becomes separate word in it. And if we create sentence representation of these two sentences, so vector representation of these two sentences, we have ones where we have exact word matching with our vocabulary. As simple as that. Do I need to? You can come closer, it's fine, or you can ask me later. Okay, so what are advantages? It's fast, efficient, it's good with exact matches, it's very easy to interpret, as you saw, well, I could explain it so simple so you can understand it as well. It misses semantic relationship, it's sensitive to wording variations, and poor with synonyms and paraphrasing, so it doesn't understand the context. As you saw, without stemming and lemmatization, speak and speaking were two different words. I personally use BM25 for sparse vectorization. You can try also TF, IDF with scikit-learn. A bit harder, dense retriever. We use embedding to convert our text into meaningful vector to capture semantic meaning. And here are these two sentences that I just mentioned. They have a very well, difficult to understand vector representation. It's just numbers from -1 to 1 here. And usually, well, it's just for the sake of example. They are way longer. There's hundreds and thousands of dimensions. Pluses, it understands better semantics and handles synonyms well, good with paraphrasing. Remember disadvantages of sparse retriever? Well, it can do it. And it's context aware. It is computationally expensive and requires more storage. And it's harder to interpret, we couldn't do it, may miss exact matches. Usually, if you want to choose your embedding model, it's massive text embedding, benchmark, leaderboard, and Hugging Face, always nice. If you want to implement only a dense vector search, ChromaDB supports, I think, only this. And another is Facebook AI similarity search, good for dense vector search and dense vector clustering. When we combine sparse and dense retriever, we end up with a hybrid retriever. It is better for overall accuracy and combines benefits of both approaches. It is most complex to implement, and it has more maintenance overhead. I usually use vector database that has pre-built this feature. I use Pinecone, I love it. I heard also lots of good about Vevit. If you want just to start this discussion about LangChain or about a hybrid retriever, check LangChain hybrid retrievers. But in hybrid retriever, we need to choose our important weights of the sparse and dense parts. So when we think that they are equally important, we end up with a hybrid, so balanced hybrid retriever. When we have, for example, technical documentation with lots of specific terminology, then keyword-focused hybrid retriever with 70% importance going on a sparse retriever might be a great deal for you. If we are talking about some narrative where context is important, so some semantic meaning, well, then it's semantic focused, or we add additional layer of search and we add some metadata. And if we do not want to do it manually, we can use named entity recognition. It is a technique that identifies and classifies named entities in text into predefined categories like names, organizations, locations, dates, and so on and so forth. So here I have a sentence. Andrew Nunn published a paper about deep learning in Nature journal while working at Google Brains. When we apply named entity recognition technique, we have Andrew Nunn person, well, apparently. Deep learning and Nature will be two organizations, and Nature and Google Brain will be two organizations, and deep learning will be technical term. And this way, we can extract this metadata from our text and store it as a metadata again in our vector database. I use Gleaner. I heard good about Flare and Stanford named entity recognition. So we already almost there. We had chunker, we had some retriever. How else we can improve the context that we pass to our prompt augmentation? We can use re-ranking strategies. And the first and the basic one is a time-based weighting when we score our documents based on their age, applying some sort of time decay to weight gradually. So imagine we basically prioritize always the newest documents. It's easy to implement, it prioritizes fresh content, and it has configurable decay rate, which also can be a disadvantage sometimes because you sometimes need some domain knowledge. It can over-penalize classics, and it's not suitable for evergreen content. Another is a source authority weighting when we weigh or re-rank our documents based on the credibility and reliability of the source. In this example, I have academic paper having higher importance than a forum post. It promotes reliable sources, it supports quality control and reduces misinformation risk. Though it may miss emerging experts, imagine you're always checking some academic papers, but there is some emerging author from Medium that really disrupts and gives you something new knowledge. We will just miss him. That's a problem. So again, we have subjective authority tuning. We need to have some domain knowledge, and it needs regular updates of authority scores. If you have very emergent field, well, that's something you will need to do. Something harder, and my favorite, because it's, well, automatic, it is cross-encoder re-ranking. It is a neural architecture that processes query and document together as a single input to determine their relevance. On the slide, you have an example of a bi-encoder, and bi-encoder is the initial retrieval strategy that we use. We have a user query, we embed this user query, it is encoded, we connect to retriever, and it connects to the vector database that already has encoded documents, and it, well, compares the similarity of this query and the documents in there, and speeds us this top-end chunks. In cross-encoder situation, we have additional layer. We have this top-end chunks, and we have a query. We encode them together to capture this relevance closely, and then it gives us this top 5, for example, chunks that you wanted. Think of it as, in a bi-encoder situation, we have two people watching movies separately, writing reviews, then they're coming together, they're looking at their reviews, and they're trying to understand whether this movie was good or not. In a cross-encoder situation, these people would watch movie in the same room and discuss it and try to understand right there if it's good or not. Gives us higher accuracy, better understanding of query-passage relationship, more nuanced ranking decisions, but it's computationally expensive, it requires higher memory, and, well, of course, lower inference time is something also that we need to face, and it's not suitable for initial retriever. I named lots of approaches and techniques, but I didn't mention how to choose it. One option, of course, you can ask your colleague, and colleague will say, well, use it, or you can go through evaluation. And evaluation, we have some very basic, again, metrics that will be good for retriever, chunker, and re-ranker. It's not the whole list of the metrics, but, well, good news, we can use it. Or, of course, you can also use human evaluator, but it will cost you money, time, and gives us some bias. So how we should use it? We need some ground truth. And for ground truth, we need to create evaluation data set. And, well, we do not need to create it manually. We can, again, use LLM. So we need to take a slice of our data that we will have in our RAG, and we want to ask LLM to create a question answering couples or query response couples, as you prefer more. And well, usually LLMs are very good with it. But still, don't trust it fully at the first iteration. We want to cross-check our output with either another LLM or human evaluator, because we want to make sure that this question and answers are, of course, first of all, right, given the context, and clear, specific, and realistic, because we do not want any weird questions coming as our task questions. Then, once we have this QA data frame, we can define our metrics and start iterations. On the first iterations, we have some benchmark, our basic embedding, our basic chunk sizes, our base embedding model, everything simple, and like some dense retriever. On the next iteration, or for example, for top performers, we will try named entity recognition, or we will try some re-ranker. And this way, we can see how our, for example, precision at K progresses over time and which specification lead to this. And actually, that's where I would like to stop. I would like to thank you all that you came here so early. Well, that's really, I'm impressed. I wanted to ask you something else. I'm now conducting research on efficient RAG benchmark. If you can please scan QR code. It's not yet a questionnaire, it's just that you at some point would like to participate in it. Apart from this, thank you all and have a great rest of the conference. Well, if there are any.
Thank you for the interesting talk. I have a question regarding the context size of the LLM that you are passing this one-shot prompt. So that context size is always limited, and it depends on the size of the LLM itself, which has a major impact on also the overall retrieval process. So imagine you have a file which has like hundreds of pages, PDF files, and you are indexing it, and you use all this semantic search and so on. In the end, some chunks will not be retrieved because even though they are relevant, due to the whatever reason, they might not be completely retrieved. And even if they are completely retrieved due to the context size, you are not able to pass all of them. You need to omit some of this to fit to the context size. So how would you handle such situation after you get, for example, maybe not very good results in terms of accuracy? How would you tackle this?
So, I don't know, works or not? Okay, so first of all, it depends on the use case. You said you have like 100 pages. And that's where you need to define like, your chunk size and then your context length. Well, it always depends on your user case. And well, if you have the document and you know that you have limited capacity constraint, probably you shouldn't go for some semantic or agentic chunking, and you want to have some fixed length if you know that there will be some situations. So that's always some trade-off. If you have some like situation that you faced, like we can discuss it like after the presentation. I will give some more insights because I do not want to deep dive super technical on this side. So just approach me, we can discuss this way.
Okay, thank you.
Do you see any future of RAG? Because some of them argue that the context windows are getting larger and larger, and so we don't need RAG anymore in I don't know when.
Sometimes it stops working, then it starts again. So again, there are lots of now variations of RAG, right? There is a graph RAG, and there is this. And I do believe that like probably in this vanilla version of it, of course it's gonna soon die out, but I never know what comes through, so it comes soon, right? So I would say that there will be always some need of RAG, because most companies do not have the capacity to train their own models, and for some cases, well, it's just there. At some point, it will not be as novel, and that's it. We will just have it as a norm, as any QA chatbot in the bank or whatever, you know.
Hi, interesting presentation, thank you. So I am myself building some RAG system, and a problem I encounter is that I have to process some email template, and I want absolutely that they are kept as one chunk in the when chunking. So which approach would you use to make sure that these things that should not be split are not split?
Repeat the question, please. I really...
Sorry. So I myself build a RAG system where there is email templates in the documents I have to process, and I absolutely don't want them to be split, as basically I want the generator then to basically spit out the email template as is without any alteration. So which way would you use to chunk, to chunk and make sure that this content that should not be split is not split?
Well, you always have some, so when you define your, because once you decide that you want to have this chunking approach in your data management pipeline, you also can, like for some documents have, or some like unique ID documents to have some exceptions. Like also I decided to split the data management pipeline slide, how it would look like. But again, I have it with me. So again, these two questions we also can, like in the previous one, we can discuss afterwards. Should I then be unwired or? Okay, sorry.
On the evaluation side,
Yes.
yeah, you mentioned that in the last slide that it would be a step to choose the metrics. I know that there are quite many kind of evaluation framework out there that provide some metrics out of the box. I don't know, can you recommend any? So kind of, I know, for example, Ragax, Phoenix.
Yeah, I heard a lot about trying Ragas, and sometimes also people use Blue and Rouge, even though like one of it is for translation, right? So we want to track specifically how this part of the retriever configuration influence our, well, the later point. Ragas can evaluate your system as a whole, basically, and it will evaluate not only retriever, but also generator part. So you will not have this zoom in into specific which part leads this. Therefore, for first iterations to choose the modification of retriever, I would stick to some like precision and recall at K. Yeah, that would be the first. And then if you want to have some like, I don't know, evaluation ongoing, you can use Ragas when your system is basically done. When you're just talking about like retriever or something, it might be an issue because Ragas is full basically scope, and in RAG we have this retriever and generator separately, and we want to have to see the influence of each. Yeah. Okay. Can I get unwired? Thank you, everyone.